Welcome back to the Contextual Electronics Podcast. My name is Chris Gamble, and this is episode 4. Today we're talking to Elen from Fully Automated Technologies, which is an open source design shop out of Vienna. And Elen is a really exciting electronics designer. She's self-taught, and they are working on high-powered systems and all open source. So all of those things together, and all in KiCad too. So obviously I'm very excited about that. Following Elen on Twitter, I got to see a lot of the stuff that she shares every single day, and seeing the things that they're building is really, really impressive. Also exciting, it wasn't announced in the show, so you hear it like that, but it actually has been since announced. It's called IDEA, and it's a new site for sharing like modular blocks. So basically having like a schematic and a bit of layout already done that you could go and drop into your project. And so that's really exciting. That's a new development. We'll have links for that down in the show notes, so please check that out. And Elen will describe that as well. So we're now on our 4th podcast. We really appreciate everyone who has subscribed and listened and watched so far. If you haven't, please do subscribe on YouTube and hit the little notification bell so that you hear about the new episodes. If you're on a podcast listener, please go and subscribe there as well so you can hear about the next episode. So here we go with Elen from Fully Automated Technologies. Welcome to the Contextual Electronics Podcast. Today I'm talking with Elen. Welcome, Elen. How are you?
Hi, I'm fine.
And you run Fully Automated Technologies, or automated.ee. Can you tell us a little bit about that?
So Fully Automated Technologies is basically two things. It's for one, it's a collective of hardware and software developers, and the other thing is also it's a company too, where we do consulting for mostly electronics projects, and which are all open hardware. So our main focus is with open hardware, and so we're building open hardware in the open, and are very public about our projects, and tweet a lot about it, and publish all the schematics and informations. I mean, at least when it's finished, because we've a huge pile of unfinished projects, and yeah.
That's great. So tell me about that more. I mean, so I first off, I love open source hardware.
Mm-hmm.
I learned so much from it, just being able to see the various projects that are out there.
Yeah, me too.
How does it actually impact a business versus just being able to browse it, or individuals that might be posting?
I mean, to do it as a business is really hard. I mean, basically, it's we're still in the very early stages, and we're not making that much with actually selling hardware and the consulting, but we're getting there slowly. And so also in the beginning, like every company, we had some setbacks and everything, and struggled to get through. But it's looking good now, and so that's really amazing. Because it started out as, okay, we want to do open hardware, and let's just try it and see if we fail.
Mm-hmm. Yeah, and it's great. I mean, that's a great way to take it too. I mean, if you need to, right? If customers are like, well, we'll never possibly do this, then you can always say, okay, well, reevaluate. Say if it's going to be a business or something else. And that's great. It's been working out. What kind of customers are willing to do open source hardware? As from their consultants, from people that they're paying to do design work.
Mm-hmm. So right now it's mostly for smaller projects. So people who come to us with where they want to go into smaller series production and stuff like that. So, for instance, where we designed power supplies and for a single board computer cluster and stuff like that. But at the beginning, we also designed a large battery pack with which covered basically very frigid climates, and which was actually the project which then fell through. But
that's a tough one for. I've done some lithium-ion stuff in the past, and I was shocked to learn. I'm like, oh yeah, there's like water in there. Like they'll just freeze up. You just can't. You can't.
Yeah.
So tell me more about that. What are the challenges of doing like low climate or cold climate electronics?
So the main challenge was at first sourcing the cells. So we had to find a provider which actually could deliver us with lithium iron phosphate cells, which actually work down to minus 20 or 30 degrees Celsius, that is. Mm-hmm. And so we only found one vendor which also sells them in the EU, and yeah, so basically we had to go with those, and
Right. And
but
that
that worked
already
out.
limits your supply, and then
Yeah,
that's a
yeah,
dangerous situation for any company to be in, I think.
yeah, exactly. And but it's still an established supplier, and yeah, so we
Well, that's good.
didn't
Yeah.
worry too much there.
Mhm.
And also we took a whole crate of cells at the beginning, so
Right.
yeah,
Right. You have to take what you can get, and yeah,
yeah,
if the
exactly.
minimum order quantity is
Hmm.
250, then you're buying 250, and you have a bunch sitting around for later.
Hmm. Yeah, I mean, we ordered 40 cells because they're really big, and they were 40 amp hour cells. And so, yeah, I don't have any around here right now to show, but they're really huge and also massive. They weigh like 1.6 kilos.
Oh wow.
And yeah.
Wow. Tell me more about the so some of the other projects. It seems like a lot of the projects you're doing are power focused. Is
Mhm.
that for a particular reason? Is that like because the customers are looking for specific things, or why power?
Well, because that's how we started out. So, starting with the whole open hardware business, actually, I was only learning about the hardware and about doing electronics professionally.
Hmm.
So, because I started out with my partner, Zoe,
Hmm.
and she's a power electronics engineer and has lots of experience there.
Hmm.
And it all started out because we wanted to make a portable battery management system which could basically power everything we need, like laptops, phones on the go, everything.
Hmm. That's
And
the dream of having that one device to rule them all, huh?
yeah, exactly. And that's just the Napkin project, which everything started out with. And yeah,
Mm.
oh
That's
yeah,
great.
I have one of the cells here right now.
Oh wow, you were
So
kidding.
yeah, they're really massive. And
Wow. And you said 1.6 kilos for that. So
yeah.
what is the target for that? Is that like for like cold climate like vehicles or something like that?
Yeah, it was for an semi-autonomous vehicle, so it was for
Oh wow,
basically a snow plowing robot.
cool. Okay,
Yeah.
that's really cool. So you mentioned that your partner was a power electronics
Hmm.
engineer and that you got into it. So I'd love to hear more
Yeah.
about how you were getting into the electronics world, and
Hmm.
then what some of the tools you were using to learn,
Yeah.
and just kind of your general take on
Hmm.
moving in the
Yeah,
electronics
definitely.
space.
So basically, I was always interested in electronics. I just had no one to really teach me about it. So I always struggled with the basics and, okay, where do I go from there? And I had no one to really show me how it goes. And also, resources were always quite limited and when starting out. And
Yeah.
like, also had electronics course at school, but it was also very basic and everything.
Hmm.
So I only really started way later and was just doing software in the meantime.
Oh, great.
And
So what kind of is it? High level software, low level software? What kind of?
basically everything.
Okay, cool.
Yeah, so did some Arduino stuff and microcontroller programming, but also IT security and high-level stuff like web applications and yeah, basically everything in the whole stack. It's yeah.
Yeah, that's great. And so when you say resources, do you mean resources like the money to buy equipment, or more the learning like educational materials and kind of?
Both actually.
Okay.
So yeah, um,
And so
like.
so when you came into it, then so was it
Mhm.
because so did you end up using kind of low end equipment, or did your partner have some kind of more established equipment to kind of learn on, or what was
Um, mhm.
your path kind of moving in there?
Yeah, so basically, we just started with some breadboards and perf boards and a multimeter and a soldering iron, and
Hmm. Yeah.
worked our way up from there. And as we progressed and made more complex projects together, we bought more equipment, like
Hmm.
yeah, the Sigland oscilloscope, and
Yeah, that's a good one.
yeah.
Yeah, so that's like basic bootstrapping method. Use
Yeah,
your
exactly.
money to buy the next thing, to buy the next. Yeah, recently I've been getting into RF, and my
Yeah.
other project money gets to go buy the
hmm
RF equipment, which is
Yeah.
is not cheap, unfortunately. I really wish it was more accessible.
Yeah, RF is actually one of the things I also started out with
Oh,
because
really?
so way back in school, I got a ham license and built a small continuous wave transmitter, and basically that was the most complex thing I did at a time, and yeah, shelved it then again because yeah.
That's great though. That's a great. I think a
hmm
lot of people come in from the ham radio, amateur
hmm
radio. Yeah, that's like a great interest. For me, it was always the mental leap from like. I always felt like in ham radio, the focus at the beginning is always on using the radio, and then I
hmm
was always like, but I want to build the radio.
Yeah,
And
exactly.
and
I
did you get
mean,
into
that's
like
how.
QRP and like the smaller stuff then at some point?
Yeah.
Or
I mean, I got into it because I was basically interested in the RF stuff and less in actually working stations. And
yeah.
to this point, basically have very few actually connections made over the years. And
Yeah. Same
so
here.
basically, yeah, I
I have
just
my license and I've never
yeah,
used. I've like literally never used it,
yeah.
unfortunately. Yeah, KD8 RND I think is my call sign. I think I
hmm
have to. I even have to struggle to remember to my call sign. So
Yeah.
that's pretty telling right there.
Yeah, I have Oscar Echo 1, Yankee Echo Echo.
Oh, nice. That's great. And it's great too
Yeah.
to like to see different regions
hmm
and see
Yeah.
how that works. And you mentioned you're in Austria, and
hmm
what is the electronics industry like in Austria?
Um, it's hard to say. So it's basically very localized in a few parts or regions and of cities and stuff like that. So within Vienna, within the city limits, there's not much, but outside the city limits, in the suburbs, basically,
Mm,
there's one where there's more electronics companies and stuff.
yeah.
And but there's also where I went to school in Villach in the south of Austria.
Hmm.
There's of course Infineon, which
Oh, yeah.
is a huge company, and lots of people from school went to work there as network engineers.
Yep. That's great.
And yeah,
Oh, cool.
so
Yeah.
it's not that much, but there's something.
Yeah, and I think that finding any kind of community, like people that you can work with and learn from as well. I mean, that's super important if you could find it, and if not, then we have the internet, and
Yeah,
that's the nice thing
exactly.
too. And I really like that. So you are always sharing on Twitter like the
hmm
photos of these projects
Yeah.
that you're building. Can you walk me through some of these projects here? I'm going to actually share the screen so that people can see them
hmm
here. So you have
Yeah.
means of
So
energy storage.
Yeah, so that's still the pictures of way when we started out, and when we published some stuff on Hackaday.
Hmm.
And so it got way more complex from there. And
As things tend to do, yeah.
yeah, so that was our first take at the battery management system, which we wanted to make to power all our stuff.
Hmm.
And from there, it went to the really big battery management system, which was for the 1.5 kilowatt hour pack,
Mm.
and which we designed so it could do 120 amps quick charge.
Oh, wow.
Yeah, so the
What
goal
is that used
was,
for? That's used
Mhm.
for like car charging or
Yeah, basically. So it was 48 volts and 120 amps, so that we could recharge it in like 45 minutes total
wow.
charge time.
Wow.
Because the device had to go out quickly again.
Hmm. And is that
Yeah.
sorry, is that this one here, the Ace Square?
No,
Or
I
further
mean
down?
that was part of it.
Okay, okay.
But it's unfortunately on the website everything is still the old revisions and
The
everything.
documentation
Yeah,
trailing edge. Yes, I know
yeah,
how that goes out all too well. It's
hmm
it gets up there eventually, but then there's pieces
yeah,
on, Twitter, I might
hmm
share because it's screen share or something like
yeah,
that. It's like I'll document when I document it.
hmm
This is mostly for me. So
yeah,
that's good.
exactly.
That's good. So, well, that's great.
Yeah,
So you said 120 amps at
hmm
45 volts. Is that right?
48.
48 volts. Okay, so like an
hmm
industrial bus kind of style or
Yeah.
something.
hmm
Wow, wow. So what are some challenges then? So I mean, when working with that kind of like high levels of current, is
Mhm.
it do you have to take safety precautions? Are there certain design considerations that you've learned from that?
Yeah, definitely. So we tried out a few things, and also to keep the costs down, because we couldn't just go with 4-ounce copper PCBs, and
Right,
because that would have driven the costs up way too much.
right. Full
Um,
pure solid copper PCB.
yeah. So what we actually did was then for the bus bars where we needed to transport very so much current, we just got some copper bars, drilled some holes in them, and mounted them on the back of the PCB.
Oh wow. Okay.
Yeah, and roughed them up with some sandpaper, so they made a better connection and everything, and cleaned them and screwed them on tight.
Hmm.
And that worked out well.
And what kind of resistances are you looking to get with? I mean, I assume that 120 amps, you start to see some pretty
Yeah.
significant heating immediately.
Yeah, definitely. That's why we also built in cooling and also heat sinks and everything.
Mm-hmm. And so that kind
So
of moves into the thermodynamic realm as well.
yeah,
Did you
exactly.
have to kind of pick up the skills there as well? That's always a struggle for me.
Yeah, a little bit. So, I mean, we didn't do too much thermal modeling because it was okay. Our current path is clear. We know we know the heat resist or the resistance, heat
Hmm.
resistance of the components and everything, and roughly for the solder. So we did a back of the envelope calculation for that.
Got it. And then you just overspec everything else, and you have a heat
Yeah,
sink.
definitely.
Yeah. So and yeah, I guess these aren't going into super space constrained applications
Mhm.
either.
Yeah, no, it's fairly yeah. We had lots of space to play with, so.
Hmm. That's good. That helps a lot, especially
Mhm.
in cooling situations.
Yeah,
Do
definitely.
you have to do any kind of active cooling with like fans and things like
Yeah,
that?
we had a little small 38 by 38 millimeter fan from Sun Ace,
Okay.
and it's incredibly loud and pulls like, I don't know, 30 watts at
The
peak
fan
power.
does. Wow.
Yeah, the fan.
Wow.
It's crazy,
It's
but
like a jet engine almost.
yeah, it sounds like a jet engine. It's really fun.
That's great.
Yeah.
Wow. So
Yeah.
I'd love to go back to the learning side of things
Mhm.
too. So what are some resources that you kind of drew on? You mentioned your partner. I think
Mhm.
that's I think it's kind
Yeah.
of like a quasi mentor situation, but
Mhm.
just even having someone to ask questions to, that's
Yeah,
great.
definitely.
Um,
So that was the main resource I drew on, and I found it less useful sometimes to go to forums and or electronic stack exchange and stuff like
mhm,
that, because I didn't always know what questions to ask actually.
mhm, yeah.
And the one resource I found the most helpful was The Art of Electronics,
Mm,
hands down. It's the book is just amazing.
yeah.
I love it.
What any chapters that you are kind of lean more towards than others?
Um, yeah, because recently, or for another project, I was looking into low noise power supplies and for analog electronics and for measurement stuff.
Hmm.
And the chapter where they also handled LDOs and that stuff,
Hmm.
because I'm mainly doing switching power supplies, so
Right.
I don't have much experience with LDOs and how to really get the noise down for everything. And yeah,
Hmm.
so I like that chapter.
Yeah, like power supply rejection ratio. First time I saw
Yeah.
PSRR, I was like,
Hmm.
what does that even
Yeah.
mean? But then,
Yeah. And why is it in decibel?
right, exactly. Yeah. Yeah, that's great. I picked up the X chapters recently,
Mhm.
the
Yeah, me too.
addendum. Yeah.
Yeah.
And I was trying to, before COVID, I was reading it on the
Hmm.
train home. And so I was like on the train and like reading about like transformers and just like magnetic fields and like all these equations, and my
Yeah.
head was literally swimming as I had
Hmm.
like train noise all
Yeah.
around me. It was it's intense. And
Hmm.
yeah, that's
Yeah, definitely.
when you're doing switch mode, are you doing any like flyback style, or like what are the different topologies that you're using in the switch mode?
Yeah, so mainly buck boost or boost buck converters. And so I haven't made a flyback or a flyback and other topologies like that yet, mainly because I don't really do mains power.
Okay, yeah.
Yeah.
Yeah, that's
So
that's its own set of scary for me. And
yeah,
well, in Europe too, it's 240 instead of 120. So
yeah, and 230.
oh, 230,
It's
right?
here.
Yeah,
Yeah. So
yeah. It's
it
got
varies a
its own
bit
set of
by
scary.
country.
Oh, really? Okay, yeah.
Yeah.
Yeah, I've seen the map before. There's like a Wikipedia map where it shows
Hmm.
like all the overlap, and
Yeah.
yeah, I just know that I go to certain countries and I got to bring a certain converter and only plug my
Yeah.
laptop supply in because it's got the auto switching in there.
Yeah, definitely.
That's great. So when you're doing like a buck and boost, what
Hmm.
are the, are you doing like the calculations around the inductor sizes and things like that? I'd imagine at the currents you're talking about, it's pretty intense on the currents.
Yeah, I mean, definitely. I mean, depending on which power supplies. So there's also lots of low power stuff, which with
Mm.
small inductors and high switching frequencies. But yeah, so basically we're using lots of TI stuff. So the datasheet is usually excellent, and so just following the datasheet and with the calculations is leads to very good results.
Yeah.
And yeah.
No, that's definitely the so when we do contextual electronics, we do a lot
Hmm.
of like pretty much like follow, but even following, I think the reference designs can be
Yeah.
problematic sometimes, like
Hmm.
especially like I don't know, like the first time I opened up like a data sheet and I saw literally pages of equations, and then it's
Yeah.
like, wait, which one of these, I wish they would have highlighted
Hmm.
which ones I needed to actually change and which ones that are just like we're just showing our work here, like it can be very confusing, I feel like.
Yeah.
So yeah.
Yeah, for me it was one time when I was trying to filter the output or to make it more stable, specific ICU, because at low loads it got into audible noise frequencies with the switching, and you could actually hear it buzz, and it was
That's
quite annoying
yeah.
because it was such a high-pitched noise.
It's just the
And
power supply singing the song of its people.
yeah, exactly.
Yeah, that's great.
And yeah, there was like a whole page of formulas and okay, how to do this if you want to make it the most stable way and everything, and like a whole page of formulas. And I worked myself through slowly, and then I got to the bottom and saw the example values
Mm.
with exactly those values I actually need.
Well, it's a good exercise
Yeah,
anyways, right?
yeah,
Yeah.
definitely.
Yeah. Oh, wow.
Yeah,
That's yeah, that is, and it's almost like you'd wish that at the top they would have put like a
yeah,
check down below. We're gonna we're gonna show some of the yeah.
yeah.
Because yeah, whenever I'm usually when I'm usually pulling data sheet values and stuff like that, I've
Hmm.
actually moved into I used to follow all of the different formulas and
Hmm.
stuff like that, and now lazy me is like I'm actually just looking for part numbers first and foremost.
Yeah.
And sometimes they don't do it, unfortunately,
Hmm.
but it can be really helpful when they do, like you mentioned.
Yeah.
So. And so, like, what are the relative sizes of the inductors and capacitors you're using in a system like this?
Yeah, I mean, sizes in means of inductance or
Oh, sure. Yeah,
current rating.
actually, either. Actually, that's a good point. Either one
Hmm.
would be kind of interesting.
Yeah, so the lowest usually is a few hundred milliamps current rating. So nice, small, mostly coilcraft, cute inductors with
Mm-hmm.
between like 1 microhenry and a 15, I think,
Mm-hmm.
for the most parts. And but yeah, for the bigger stuff, it's really huge inductors. Yeah, around or a maximum 1 microhenry and sometimes even lower.
Mm-hmm. Yeah. Yeah.
Um, oh yeah, or one coilcraft, I think, 4.7 microhenry we used for the auxiliary power supply with 12 volts, 20 amps.
Wow.
And yeah, so
That's
it has, I think, a DCR of less than 1 milliohm. And
wow.
yeah.
That's awesome. Yeah, I used to work at a industrial control company, and they used
Hmm.
to talk about like a 5 volt, 100 amp supply, and
Yeah.
they talked about the number one requirement was that if there was a it needed to be able to clear the short. So if there was a piece of
Yeah.
if there's a paper clip that fell across
Hmm.
the 5 volt and ground, it got rid of it
Yeah.
very quickly. Sounds like many
Wow.
of the supplies you make
Hmm.
also could clear the short. That's great. That's great.
I hope to not find out.
Yeah, that actually, I was going to ask about that. So I
Mhm.
think when I started getting into some of the power stuff as well, and just kind of general fears about it. I mean, do you
Mhm.
have any? I guess some war stories, but also maybe just some this isn't so bad type of stories as well.
Yeah, personally, actually, I have only one story where something went really wrong, and that was at the beginning with the test battery pack and the test board, and where I unscrewed a lead, and it was still under power. Everything was still under power,
Uh huh.
and the lead just was a bit springy and jumped around and hit the board somewhere. And yeah, it got rid of the solder mask and also the copper underneath it.
Oh wow.
Yeah,
And
it vaporized the copper.
right, right.
Yeah,
Inadvertent welding. Uh, yeah, that's fun when you see a little
yeah,
spark like that.
yeah. It was a bigger one, and also the black smoke around it, and
Hmm.
so yeah, there's a nice 1 square centimeter spot which was just gone, and around it a bit of black, and yeah,
Wow, that's great. Wow.
yeah. But that's actually the worst thing that happened until now.
Okay, that's great. Yeah, I mean,
Yeah,
I think that is the thing too. Like when if people are careful, I think it's really about learning process too. Like if
yeah.
you're careful about
Hmm.
even hooking, like you mentioned, the ground is still connected on that
Hmm.
battery, and so that allowed it
Yeah.
to short because it completed the circuit. Um, but I was thinking about like doing jumper cables too. Like you take the
Hmm.
ground off, even if you touch the
Yeah.
positive, it's not going to be that big a deal. So
Hmm.
that's yeah, it's just kind of learning these things
Yeah,
over time.
definitely.
Sometimes you do have to scorch a board or two, but as long
Yeah.
as you're okay, that's the important thing.
Yeah.
So I was looking through your Twitter feed earlier too,
Hmm.
and you share a ton of great. If I can pull that up here too, if you don't mind.
Yeah, sure.
You share a ton of great layout things as well.
Hmm.
What are you using for layout, and what are some of your, you know, do you have any tips or tricks about you know, uh, doing good layout?
Hmm. Um, Practice. So I don't really have any great tips about doing layout. So I use KiCad for everything, and
Yeah.
never used anything else basically.
Hmm.
Um, yeah. Uh, so my greatest thing with layout is I want to do it clean, and I usually shift parts around and everything. And also sometimes, if I'm making a new symbol, I rearrange the pins until everything just looks nice. And
Hmm.
when I take a look at it, if it takes me too long to understand it, what's happening here, then I usually there's one of two cases. Either I don't understand it yet good enough,
Hmm.
or I need to redo the layout because it's too complex.
Yeah, that's a
So
great
even
point.
with really complex stuff and everything, you can still do a simple layout.
Hmm.
And also subcircuits in KiCad is so amazing. Like splitting the layout up in functional parts, and that's a really important thing.
Hmm. Just to help kind of understand the overall
Yeah,
how
yeah,
things
and
fit together.
also to have it so that it's not too crowded. Like
Mm.
split it up in functional parts so that you have, for instance, if it's a more complex power supply, keep the power supply in one part, and the microcontrollers and control stuff and everything on different sheets. And so when you take a look at it, and if you're debugging something, so you really have the thing you're working on right in front of you.
Mm.
Yeah,
That's
that
great. Yeah.
helps a lot for me personally.
Yeah. No, that's really good advice.
Yeah.
It's something I don't usually. I'm not always great about taking that advice either. Yeah, I'm actually making. I was just thinking like, oh, I've got a layout right now, or I've got like everything shoved down on one sheet, and yeah, it is getting a little
Yeah,
crowded in there. I should probably
yeah.
spend some time and break it up today. Yeah.
Oh yeah, I just remembered. Actually, I have one more war story about
Okay. Yeah.
batteries.
Yeah. Go ahead.
So with the big battery pack, when we did initial testing and charging, So we wrote the firmware for the LTC 6811 from Linear Technology, battery management IC. And there was, so in the end, it turns out there was a bug in the firmware, and which we didn't know, and which also isn't mentioned in, or wait, let me back up. So 4 of our cells overcharged, like
Oh wow.
these big cells overcharged, and we now have 4 chunky lithium pillows. And yeah,
And when you say that, you mean like they actually like bulged out and
yeah,
okay.
they actually deformed the whole pack, and like in one pack there's 12 of those. And so they deformed the pack, and luckily nothing broke because we used a flexible material for that. So the plexiglass pack only came later. And so it bulged out, and the aluminum gave way, the brackets and everything. So there wasn't too much damage done, but 4 of the cells, well, they're now pillows.
Yeah, they're not coming back from that one.
Yeah.
They're just they're staying pillowy.
Yeah. And as it turns out, the problem was in the firmware, and we failed to reproduce a bug fix which the LT reference code has. But the thing is, it's never mentioned in the datasheet. So there's a silicon bug where if you talk to it too fast, or if you don't have a delay in a specific point in your code, then it doesn't accept the register write. So everything works well, but it doesn't latch in the register. And so it didn't start balancing.
Oh, wow. Okay.
Yeah.
And so, and can you explain what balancing is then?
Okay, balancing is if you're charging a cell, you reach the point where you have your cutoff voltage, and you don't want to go in your cell any higher because otherwise, well, your cells blow up.
Yeah.
And so you balance either passive or actively. So passive balancing is basically you dissipate the current somewhere, usually in resistors. Or you can also do active balancing, where you then move around the current, like with DC-DC converter and some inductors, and where you basically reroute the current to the other cells until they're charged enough too. And yeah.
So that's like using, there's like MOSFETs in line that actually say,
yeah,
oh, this cell is fine, let's bypass it, or what does that look
exactly.
Like? Okay. And then, so the controller chip, you're saying, actually controls which ones are...
yeah, it controls the MOSFETs and says, okay, this one resistor should sync the current now for this cell. And yeah.
And they forgot to do that.
Yeah, they forgot. I mean, the command was written, but just it didn't latch into the register, and I was like, oh, well, that's not nice.
Right. Yeah, that's a pretty key one. So that's yeah. Well, and you mentioned programming too. So what are the usual interfaces to the control chips, and what kind of control schemes are you using normally?
So as in communication buses, or during development, or
yeah, and also like thinking like, do you have microcontrollers on board, or are they more or are they kind of off board and you plug into them?
No, they're designed on board. So in this case, it was an MSP430. Yeah, with the FRAM series, once again, because low power. So if there's a sleep mode for the battery pack, it survives like until the cells self-discharge.
Right.
Yeah, and also
not quite the heat death of the universe, but from a cell phone standpoint, it's like, oh no, a long time.
Yeah, definitely. And it also works nice in low temperatures and high temperatures. So especially on the board, it could also get hot, and
yeah. So when like flash memory might give up the ghost and go away, but what is FRAM? Can you explain that for people?
Not quite. So it's basically it's ferroelectric magnetic memory. And I don't remember quite exactly how it works in detail, unfortunately.
Yeah, I don't either actually. I thought it was just like it has like magnetic elements built into it, and
Hmm.
so it's not like I remember Flash. Well, I used to work on Flash, but it was like
Hmm.
Flash is basically you're like crossing a barrier, and you've got like basically
Yeah.
electrons that are hopping through a
Hmm.
oxide layer, and I think with the magnetic, it must be flipping positive, negative, or something like that, some kind of polarity.
Yeah, it's flipping the polarity.
Yeah. Well,
So you're
it seems to
magnetizing
work.
it. Yeah. I mean, the Wikipedia page also explains it nicely. So
Yeah, right. We'll try and link that in. That's great.
yeah.
So coming into it, I mean, did you had programming experience? I mean,
Hmm.
how was it translating that to like a microcontroller, like an MSP430? Was that pretty seamless?
No, not at all. It's yeah, so it's quite different. If you're not used to just directly working with registers for everything, it's quite a transition.
Mm.
So especially because MSP430 is less hardware abstractions, and you just take the reference manual and flip bits in the registers directly.
Uh-huh.
So that was at the beginning it was really hard, but yeah, after some time and when you get into it, it gets really easy.
Yeah, I find the most important thing for me, and again, of advice that I don't take very well, is like to start with a known example. And the thing
Yeah.
I always seem to do is like I'm like, you know what? I'm not going to use the Windows programmer. I'm going to go and just like try and do it all myself, and use
Yeah.
GCC. And it's like, Chris, you should just do that later. Yeah. So and like starting from examples, I feel like
Mhm.
I started on a project a couple months ago, and like just
Mhm.
oftentimes the examples have so much stuff that you can grab and use that
Yeah.
it's just like that's the place to start from.
Also, the worst thing is sometimes the examples just don't work.
Oh, that's true. Yeah, yeah.
Yeah.
How is the programming environment for MSP 430?
So I programmed with Eclipse, so Code Composer Studio, and
Hmm.
I mean it's heavy and everything, but it works in the end. So it's
Mm, yeah,
yeah.
yeah. And I think the other thing there is like if the support forums are all using that, and it's like
Mhm.
basically you can make a choice like I tried to with like going to
Yeah.
GCC and doing everything your own
Mhm.
way, but then it is a lot harder to find
I
support
mean,
and
yeah, for ARM, it's more fun to go the GCC route, and
yes.
because there's just so much more. And for MSP 430, it's yeah, there's not much there.
Yeah, yeah. You pretty much you get the what is it? M430 is that one of the forums?
Uh, yeah, but I don't know how active that actually is
Oh, really? Okay.
anymore.
It
Yeah.
used to be, I remember, but that's yeah.
Hmm.
I haven't used an MSP 430 in a long time, and even
Yeah.
then I used, I think like a silly simple dev board, and that was it.
Hmm.
So yeah.
Yeah. We used especially in that one because it had a really nice feature. They call it a smart analog combo.
Okay.
So it had basically ADC, DAC, and op amps integrated 4 times,
Oh, nice.
and which you could reconfigure. And so it's one of the more modern parts of the MSP 430. And yeah, that was really interesting to play with, and basically the reason why we took it.
Yeah.
So sounds like an interesting chip. Let's use it.
Yeah, yeah, that's great. Yeah, I think
Yeah.
it is interesting too, like because I think a lot of times these days people would ask, why aren't you going to ARM? But I think
Hmm.
so much in microcontrollers, it's just about finding the peripheral set that really fits your
Yeah,
needs.
definitely.
And it sounds like that's a really, I mean, that plus
Hmm.
the FRAM, that sounds like a really good fit.
Yeah.
So that's a great choice. Tell me more about so using DACs and ADCs, and so what are the things
Hmm.
that you're measuring, and then what are some of the challenges you run into when you're measuring this on like a power supply board?
Hmm. So the challenges aren't actually that much. So you measure two things: current and voltage. So it's just the most basic things.
Uh-huh.
And the only challenge might be that if you're, for instance, column counting, so counting how much energy flows in which direction,
Hmm.
that gets a bit more tricky, especially if you take the wrong chip, which only counts in one direction and not the other, and you want to charge and discharge. So,
Sounds like there's a story here as well.
yeah,
Is it past experience? So explain
yeah,
that. So
exactly.
so charging one way versus the other. Why
Mhm.
would that? Is that based on like the input you have to use to measure across a sense resistor, or what does that look like?
Um, I don't know, unfortunately, the internals of that IC. So
Mm. Oh, is this using like one of the INA, like one of those chips, like the
no,
integrated
that
one?
was it was also a dedicated chip from LT,
Hmm.
a column counter chip.
Oh, okay. Okay, cool. Yeah, and I've been doing that recently. Actually, I was using a fuel
Hmm.
gauge
Yeah.
chip that was just like an off the shelf, just to
Hmm.
I remember like a couple years ago, I was like, I don't know how any of this works because like lithium ion curves, they have that
Hmm.
weird, it's like flattened
Yeah.
out in the middle, and so that's why you
Hmm.
need to do some Coulomb counting.
Yeah.
Is it fuel gauge style chips that you're talking about, or is it something more base level?
Yeah, it was a fuel gauge type chip,
Uh-huh.
but I don't exactly remember which part it was anymore. So
Mm. Yeah,
unfortunately,
that's
I
okay.
don't. Yeah, but I think it was mainly column counting. So because fuel gauges usually have their impedance track algorithm and
Hmm.
everything, and
Yeah.
do much more stuff, and maybe even have a digital core in there somewhere.
Uh-huh. Yeah.
And
Yeah, it's nice because then they
yeah,
spit out. It's like you just talk
hmm,
to it over I squared C or
yeah,
whatever, and it just is like the reading's 87%.
hmm,
It's like
yeah,
okay,
exactly.
whatever that means, like.
Yeah.
But yeah, that's really cool. So you basically talk directly to like a Coulomb counting chip,
Hmm.
or is it so that's spitting out digital
No,
values or analog
yeah,
values?
it was also over I2C.
Okay, great. Yeah, yeah, yeah. That's cool. Yeah, and it seems like the one I'm talking about is like a tiny little, just
Hmm.
like a, commercial,
Yeah.
consumer level chip. But you're talking about like
Hmm.
these industrial level because you're charging such large batteries.
Yeah.
It's yeah. Did I ask yet like what are you using? So you mentioned some of it was like the power supply, like to one power supply to rule them all. But like, so like, are your customers doing like snowplow style robots and stuff like that, or what are these being used for eventually?
I mean, that was just that one customer, and in the end, the whole project fell into the water basically right at the end.
Okay.
So it never got used anywhere,
Got
actually.
it. Got it.
Yeah.
But like other customers, so like who needs this kind of like the large style? Is it like quadcopters or like who is
I
actually
mean,
using
for
this
a
most?
quadcopter, it would be quite a bit too big because
Mm.
in the end, one of the packs, and the robot used two, one of the packs was 22 kilos.
Oh, okay.
Yeah.
Okay, so maybe
So
maybe a really big like those
yeah,
rideable
I mean,
quadcopters now.
and also this pack in particular was just developed for that customer, so we didn't have another one for that.
Got it. Got it. Okay.
Yeah.
So I got really confused at the beginning of like learning battery chemistries and stuff like that.
Hmm.
Can you talk through like some of the different battery chemistries and
Yeah,
like
sure.
the like how you learned about them all?
Hmm. So basically, I learned about them all just by looking them up and being curious and looking up chemistries on Wikipedia and reading data sheets for battery cells where I could find them.
Mm-hmm.
And yeah, so basically nowadays we just use lithium ion or lithium polymer mostly batteries, for instance, in our smartphones and gadgets, and they are everywhere.
Mm-hmm.
And but also so the upside is they have a large energy capacity, so large amount of yeah energy
Capacity and stuff. Yeah.
per
Yeah.
kilogram, and
Yeah.
but they also have a lower cycle life, so you can charge and discharge them less often until they start to lose capacity.
Mm.
And that's then where lithium iron phosphate, LiFePO4, comes in.
Mm-hmm. Yeah. I always
And
try and pronounce it. I'm like
yeah,
Leifipo.
yeah. And yeah, so they survive lower temperatures and have a lower voltage also inherently. And but they survive for longer. So if you have something which doesn't use too much power and for instance, would be outdoors and should just survive a long time.
Mm-hmm.
Yeah, go with those.
Okay. All right. That's good to know.
Yeah,
And then what about
and
using like versus like a lead acid or something like that, like just the traditional car battery?
yeah, I mean, lead acid batteries. I mean, if you're fine with dealing with lead and acid, then they're fine too,
Uh-huh.
especially because they're cheap. So they're compared to lithium ion batteries, batteries. Ugh. they're still extremely inexpensive, and they're so ubiquitous. You can just pick them up somewhere and
Yeah,
get
go
them
to
for
an
cheap.
auto part store
Hmm.
without,
Yeah.
the less shipping restrictions or same shipping restrictions?
I think less shipping restrictions,
Mm.
especially with anything that has lithium on it, written on it. It's a nightmare to ship.
Yeah,
It's incredible.
yeah.
Yeah,
And so are your customers far enough away that you have to deal with that sort of thing?
yeah, definitely. So that was the main problem we ran into because
Mm.
even though, for instance, lithium iron phosphate batteries are inherently safe and they don't burn and they don't explode, they just,
Oh, they don't?
yeah,
Okay.
yeah. If you mishandle them, they will just bloat up and mechanically maybe destroy whatever you put them into, but they won't burn.
That's
And
good.
also, they don't get too hot. So even the overcharged cells, I think I have some pictures I took with Fleur somewhere where they had like 75, 80 degrees Celsius.
Oh, wow.
So it wasn't even too bad regarding the heating.
And that was like when they were in an overcharged
Yeah.
state condition or
Hmm.
something like that.
Yeah, and they were also discharging gas.
Is this was this a scientific experiment, or was it like you had made a mistake and then you're like, wait, let me get the flare out?
No, that was. I mean, that was still the same story with
I got it.
with
Either
the
way,
bug
it's
in the
awesome.
firmware.
Either way,
Yeah,
it's awesome. Don't get me wrong. It's
yeah. No,
that's great.
it's. I mean, if the cells wouldn't have been so expensive, it would have been a really nice learning experience
Yeah,
because
right.
I mean,
Yeah.
also, if you just take an 18650 style lithium iron phosphate battery and just want to overcharge that to see what it does, I mean, just keep a bucket of sand nearby, but it won't explode on you. Like, for real. The chemistry is inherently way more safe than lithium ion or lithium polymer.
Okay, that's great to know. Yeah, I mean, I've had I've had a couple mishaps myself. I had
Yeah.
one person, it was not me. It was someone in my workspace
Hmm.
who was playing with these, and they were like trying to like package them into like a box, and then they caught. I think they put a screw near, like the
Yeah.
screw went into it, and the whole thing went off, and it was just like it
Yeah.
was so scary. I was just
Hmm.
like and smelly, and
Hmm.
and we were all running for our lives, and
Yeah.
then we figured out like what was going on, and then they tried to turn it on
Yep.
again, and I was like, what do you? Anyway, that's a really great thing to know
Yeah.
though that the so it's the lithium polymer. What's the name again? The life PO.
Yeah. Lithium iron phosphate.
Lithium. Okay,
Hmm.
lithium ion phosphate. And then so is there a significantly different like charge curve when you're dealing with those?
Yeah, actually, yes. It's for lithium iron phosphate. It's the charge curve is very flat. So also the discharge curve. It's like it goes up in the beginning and then very slowly stays at the same point, at the same voltage, and then at the end it only goes up to the discharge cutoff voltage.
Okay. And so
So
that must be
yeah,
harder to actually do. You must have to do like the Coulomb counting in order to really tell where you
exactly.
are in
Hmm.
this life cycle.
Exactly.
Huh. What about one thing I struggled with when I was getting started is like sourcing batteries. I think
Hmm.
maybe because there was even less stuff around. But like,
Yeah.
what is your go-to source for finding supplies in this area?
Mhm. So for round cells and smaller cells, there's one store in the Netherlands which ships cells within Europe, and which is really nice.
Mm.
And for the bigger stuff, we found a specialty supplier for energy storage systems, and which then sold those bigger cells. So it's basically just searching on the web and trying to find something which looks, yeah, which looks like they will sell to you as a company. And
Yeah.
so, yeah, like if they only sell vape cells and stuff like that, it's
Yeah, right. Well, they're probably, buying from the same suppliers
yeah,
that you eventually want to buy from
yeah,
and
definitely.
reselling them. So
Hmm.
yeah, that's It's some of the terminology kind of got me at the beginning too, of like
Mhm.
18650 is like the size of the cell. Are there other?
Yeah, so it's 18 millimeters in diameter and 65 millimeters in length.
I actually didn't know that. I learned something today. That's good to know. Okay, so there are other sizes that you use by standard. I guess
Mhm.
does that big yellow one that you showed, is that like a standard size or is that
No,
specialty?
it's a specialty cell from the manufacturer.
Okay. But internally, is it like there's two pools of liquid in there, or is it actually just a bunch of 18650s in there?
No, it's usually pouch cells.
Oh, pouch cells. Okay. Okay.
Mhm.
And then are there standards on the pouch cells, or is it more
No,
like you
there are
just?
no standards on those,
Okay.
as far as I know. I mean,
Okay.
standards from the manufacturers, but
Sure.
not like with round cells.
Right. Yeah, but not across. Yeah, like so one
Yeah.
manufacturer would be like, oh, well, we have a
Hmm.
standard, the
Hmm.
4520. Yeah, you got to buy the 4520. And then that doesn't mean anything about
Yeah,
anyone else. Yeah. Okay.
definitely.
Okay. That's great. That's great to know. I did see there was a video a while back that showed like in a China factory when they were making the
Hmm.
pouch cells, and that was like super interesting.
Yeah.
Uh, have you seen like the videos like that?
Some, yeah. It's
Yeah.
yeah, but they usually don't show you too much, unfortunately. Like still trade secrets and everything,
Right.
and so you always just see part of the process, unfortunately. But
Mm.
it's really interesting.
Yeah. Yeah. So then, okay, so we're talking kind of the mechanical stuff as well. I mean,
Hmm.
I imagine that we talked about the heat and the fans and stuff like that,
Hmm.
but are you then repackaging these systems for your customer and doing like a full integration system, or is it more, you ship them a board and let them put it wherever they want in their system?
I mean, whatever they want. Like, if it should be a fully integrated system, then yeah, we can usually do that if it's not too complex. Because I mean, we're not mechanical engineers by trade, so it's if it's something simple enough, yeah, we can draw it up in SolidWorks or FreeCAD or something,
Hmm.
and do basic designs. But if it's getting too complex, like we say, okay, here's the board, take it. We can make it any size you want,
That's
and
right. The
yeah,
rest is on you. You gotta
yeah.
hire
The
a
rest is on
mechanical
you.
engineer. Yeah, you just mentioned the acrylic as well. I wasn't sure what
Mhm.
an aluminum, so I wasn't sure how that was getting packaged
Yeah.
as well.
So basically, we used 2020 aluminum extrusions for the sides and 3 millimeter thick aluminum plate, which we laser cut. Or ordered laser cut to size, and
Hmm.
where the cells rested on. And the acrylic was for the sides, which didn't need too much structural integrity, but it's still rigid. And we can also nicely engrave it with logos and
Yeah.
information about the stuff.
Right. Here's if you see flames
Yeah,
in here, then you should run.
yeah. Like handle with care.
Yeah, that's a good.
Don't
Yeah,
short terminals,
that's right.
and
Right. No sharp objects, please.
yeah. Also, maybe a serial number or something.
That's probably good too. Yeah, that's great. No, I think that I really like this is a great example of like bringing together all the mechanical and the
Yeah.
firmware and the electrical, and it's, a system that is has the potential for being
Mhm.
dangerous, but it sounds like you're building these really nicely spec'd systems that are
Mhm.
custom, and yeah,
Yeah.
I really like hearing about this kind of thing. So,
Yeah.
what else should people know
Recent.
about
Hmm?
you and your company?
Sorry.
What else should people know about you and your company?
Um. Hmm. So yeah, our main focus is power electronics, power design, and yeah, the main takeaway is we build open hardware. So if you have an open hardware or a project which you're okay with it being open hardware in the end, come to us, and basically that's it.
Okay, that's great.
And yeah, right now we're also doing lots of USB-C stuff. I've been posting quite a lot of it the last few weeks on Twitter.
Hmm. Yeah, I was checking that out on the Twitter
Yeah,
feed here as well.
yeah.
How do you find using USB-C? I mean, are you using like the specialty modes as well, or is it mostly?
No, I don't use the alternate modes. I mean, that would be a high-speed signal integrity and stuff like that, and
Yeah, yeah,
I don't want to get into that yet,
right.
at least. Also, we don't have the equipment to do that right now. So
Hmm.
yeah,
Got it.
but
Yeah.
for power delivery, it's really quite interesting.
And so, so power delivery, like you're using the chip that actually, or is it just, well, maybe you can explain power delivery quickly?
So USB-C with USB-C standard came also USB power delivery. And so, okay, I won't go too much in there because it's a huge and complex standard. But basically, you can request a voltage and from your power supply, and I don't know if it's current limit 2, but I don't remember quite. But basically, you can request either standard voltages or with the newer power delivery standard with programmable power supplies, you can also request a voltage in 20 millivolt increments.
Oh, wow. Okay. So that's
Yeah.
almost like you could have like a system
Mhm.
that it is like a available power supply like that, huh?
Yeah,
So
definitely. So that's what we're actually working on right now. So a
cool.
small, really cost-efficient board, which you can just take and to supply, or I mean, it serves two functions. You can, on the other end, you can put a battery, and it acts as a battery charger for your
Yeah.
lithium-ion battery. And on the other end, it also acts as a programmable power supply. So you can plug in whatever you want, which speaks USB power delivery, and just give it whatever voltage it wants. Or you can also not use a USB PD compliant board, which either has a USB-C connector connected to it or not, because there's also pins broken out for plus and minus, and to just use it as a programmable power supply.
Yeah. And
So
so then the voltages are just available, you're saying,
yeah,
on like a terminal block or
hmm
something like that.
exactly.
Oh, well, that's really
Right
cool.
now, it's still in the prototype stage because okay, we need to figure out where we want to go with it, and but the main goal is to have something, especially for makers, and to have a really cheap programmable power supply which they can use with either some whatever input source or with a battery, and which then speaks USB-C power delivery, but also so that you can just set it to any voltage if you just want to plug it into your breadboard.
That's really great. Is this the one that's showing for listeners? I'm showing a Twitter
Mhm.
screen, but is this one of the ones that is this that board that you're talking about, or is this?
It's part of the project. So this one is actually just a receiving end, basically. This one plugs into a breadboard and talks with your USB-C PPS compatible power supply, and then outputs whatever voltage you want to your breadboard. So the idea is you plug it into your PC and configure the voltage you want to have on it, and then plug it into your power supply, and it gives it out on the breadboard.
That's really great. Wow, that's super cool. How is it, and so the PD delivery? Is there a certain chip? Is
Mhm.
that this chip U1? Is that what's doing the actual handling of it, or like how do you activate that PD
Mhm.
capability?
So U1 on the picture before
Oh, sorry.
was the that's the FUSB 302. It's a USB-C power delivery USB power delivery chip, which does the whole baseband stuff and does the time sensitive stuff of the communication part. And then the STM32 U3 does the whole higher level protocol handling, and which then talks to the host to the power supply and asks it for the right voltage.
Got it. Oh, that's great. That's great. And then so you're switching to STM32 as well, so that's kind of interesting.
Mhm. Yeah, because it's much cheaper and also has USB integrated, so it's the best fit for that purpose.
Got it. To be able to just kind of plug in and
Yeah,
go
exactly.
from there.
Hmm.
Wow. Where are you? So you mentioned this is all in prototype still. Is
Hmm.
it? You said kind of. I think at the beginning you said it's open source eventually. So
Hmm.
is it? Do you share this stuff up front, or is it more like once it's kind of set to go that it gets pushed somewhere?
Um, Actually, I mean, I didn't really announce it with fanfare or anything, but it's already on GitHub,
Oh,
the
great.
whole design files, and so of the whole work in progress thing. So GitHub and under the fully automated organization.
That's great. Yeah. So we'll link to that as well.
Mhm.
And yeah, this is there a name for this specific project?
Yeah, it's a freewheeling ferret. So the first one in there.
Freewheeling ferret. That's a good
Yeah.
name. It sounds like the kind of like Ubuntu, how they have like the
Yeah,
alliterative
exactly.
titles. Yeah. I used to do that on the amp hour as well, but people
Mhm.
got upset with me. They're like, "This is silly, Chris. You're pulling too many
Yeah.
weird names." But I love doing it personally. I
Mhm.
think it's fun as hell. So
I mean, some of our projects have silly names like that, but not all of them.
I think it's memorable. You know, like
Mhm.
that's the main
Yeah,
thing is you want to be able
definitely.
to someone to be like, you're gonna remember freewheeling ferret, and I think
Yeah.
that's yeah. So okay, so one last time on the project output here. So it's
Mhm.
USB-C, and then you can either plug in with to get the power supply voltages,
Mhm.
or what was the other method? The other mode rather.
Um, so yeah, and there's also fixed voltages. So there is defined 5 volts, 12 volts, I think 15 and 20.
Mm-hmm.
And so those are in the older standard. Those are the ones which compliant power supplies had to support before.
Mm.
And if you're now going with a PPS, so a programmable power supply, they should output anything between like 5 and 20, basically.
Got it. Okay. Well, Ellen, this has been such a great look at like power and
Hmm.
all the battery stuff and this new USB thing. I think it's really great, and I
Yeah.
definitely recommend people follow you. Where can people find you and your company's work online?
So mostly on Twitter, and that's the main channel. And yeah, for projects which are in progress. And I also intend to update the website and tend to it some more, and also start a blog and to have write-ups for it.
Hmm.
And so, but that's the main avenue. And also on GitHub, in the fully automated organization, where there we publish our company-related projects. And yeah, that's mostly it.
Okay. Well, that's really great. I appreciate you this, and I appreciate you coming on to talk to us about this today. Thank you for being
Yeah,
here.
thank you. Yeah, and also at the beginning, I said fully automated is not just a company, but also a collective of people. So
Hmm.
basically, the two parts of it. And as the collective, we are also working on at the time of recording, not yet announced projects, which is a really big thing for us, and which is also being funded by the NLNet Foundation. Um, and it's called EDA. It's basically GitHub for subcircuits. So we want
Oh,
to make
cool.
it possible to easily share subcircuits, um, yeah, with the community, and to share reference designs, basically, or small parts of reference designs with which are fully routed with schematic and everything pieced together, which you can then just click and add to your board in KiCad.
Hmm. How do you do that? I know about like so you could pull in a schematic sheet, but then
Mhm.
you can pull in a fully routed thing you're mentioning as well.
Yeah, unfortunately not yet because we're still writing the tool for it.
I got it. Okay.
Yeah,
Okay. Cool.
and with KiCad 6 and the API changes they're making there, everything will become easier still. But we're working right now on open source tools, which will then make it easily possible to just do that and do the thing, because KiCad doesn't support it natively, unfortunately.
Hmm.
But we're already in the prototype stages, and yeah, I wish I would have gotten out the announcement and blog post before the time of recording it right now, but it's
We're gonna
there's
be a
just so much.
little tape
Yeah,
delay, so maybe we'll have
yeah,
some. Maybe there will be something that I'll be able to link to as
yeah.
well,
I
which would be
mean,
great.
it's going out this week, so
Oh, perfect. Yeah,
yeah.
that'll
Yeah, there's been happening so much work in the background and for the last few months, and it's extremely exciting because basically the project will be completely open source forever and free to use for everyone. And that was our main goal with this, because we just want to empower people with open source, and so to make it easier to share and to innovate together.
That's great. Yeah, and remind me the name one more time.
EDA, EDA. So
Okay.
yeah, Echo Delta, Echo Alpha.
Okay. Like, is it like IDEA but EDEA? Is that kind of idea? Okay.
Yeah, it's a portmanteau of IDEA and EDA.
That's great. That's great. Okay. Well, that's really exciting. Yeah, I'll definitely keep an eye out for that, and we'll link it in the show notes here. So that's great.
Thank you.
Thanks again, Ellen. We appreciate you being here.
Thank you too.
So that was our interview with Ellen from Fully Automated Technologies. I'm really excited about the new EDEA site. I think that's going to be a really interesting development, and I really hope that you can support it, and I will be supporting it as well. Ellen and her partner have been working on some really cool projects. I really recommend you go and follow them on Twitter. We'll have all the links in the show notes over on contextualelectronics.com. And if you haven't, you can go and subscribe at all the places like we talked at the top of the show. And please do tell other people about the show. Please subscribe here. And please also consider giving us a rating on iTunes. That helps to help spread the words. I know iTunes is... or podcast, Apple Podcasts, I guess. But anyways, anywhere you can give us a review, we'd appreciate it. We'd love to hear from you. There's also YouTube comments. There's our forum. There's a forum post that's always associated with this episode. And you can always email podcast@contextualelectronics.com. We love hearing from you. So that's all from now, and we'll see you in the next episode.